All right, properties of parallelogram. First of all, from unit, I think it was unit 4, properties of parallelogram, number 1, opposite sides are parallel, hence the name, parallelogram. 2, opposite sides are equal, as we have marked in the figure. 3, opposite angles are equal. 4, adjacent angles are supplementary. And 5, diagonals bisect each other. All right, how to prove a parallelogram. We are only going to use one of the properties up above. We are going to use 4 distances from last unit to prove the opposite sides are equal. Example 1, prove ABCD is a parallelogram. So you guys can either use the coordinates and the distance formula that involved x1 minus x2 squared plus y1 minus y2 squared and take the square root. I'm going to be more visual, so I'll use the grid. First, let's find the distance of AD. We'll make a little right triangle here. It'll be the square root of delta x squared plus delta y squared. So delta x, I'll count, is 3. Delta y is 2. 3 squared plus 2 squared. I would put just the numbers underneath the radical into the calculator, or you can do it in your head. 9 plus 4, that gives me square root 13. Now I find it helpful if we follow a certain pattern here. Since it asks to prove it's a parallelogram, I know the opposite sides have to be equal. So if I find AD first, I would find BC next because that's the opposite side. And again, what you're going to notice here when you count your delta x and your delta y is that the numbers are going to be the same. Since those two distances are the same, I can make a little conclusion here and say that AD equals BC. So I know those two sides will be the same. And now I'll just repeat this process for the last two sides. I'll find the distance of AB. All right, so I'll count this 1, 2, 3, 4, 5, 6 here, and delta x 1, 2, 3, 4. So those two numbers will be 4 squared plus 6 squared. Again, I would throw that into the calculator, just the numbers underneath the radical. That ends up being 16 plus 36, or square root 52. And then I'll find the distance of DC. And the nice part about using this counting method is that the numbers always end up being the same. If I ask you to prove it's a parallelogram, it will be a parallelogram. So delta x is 4, 1, 2, 3, 4, 5, 6. Delta y is 6. Since the numbers are the same, I don't even bother calculating it because I already did calculate it once. I get square root 52. Again, I can make a little conclusion here that AB equals DC. And finally, for all proofs, we end up with a conclusion. A, B, C, D is a parallelogram because the opposite, and you can abbreviate opposite, sides are equal. And that's the proof. All right, example 2. Prove ABCD is a parallelogram. We'll do something similar to what we did on the other one. Distance of AD. Create your right triangle. That side's 1, that side's 4. You get 1 squared plus 4 squared. 1 plus 16, that's square root 17. The C got cut off, it goes right there. Next, I'll find the distance of CB. And notice once again, 1 and 4. We get the same numbers. That always works out nicely with a parallelogram because we know the opposite sides must be equal. So don't forget to make a little note here and say AD equals CB. And now let's find the other two sides. Distance of DC. Square root. So your delta y and your delta x. Here for delta y I got 2, and delta x I got 1, 2, 3, 4, 5. So 5 squared plus 2 squared. 25 plus 4, that ends up being square root 29. And the distance from A to B, you know it's going to be square root 29, but it's a proof, so you must show all the steps. Delta x is 5, delta y is 2, so you still get 5 squared plus 2 squared, which is square root 29. And you know these two sides are equal, so you say DC equals AB. And finally, your conclusion. It's the same conclusion always for a parallelogram. You would say ABCD is a parallelogram because the opposite sides are equal. And that concludes lesson 6.1.